Alright, time for another DraftPhysics.com, debatephysics.com also. And we are in this hunt for conversation anyway. Frankly, I mean, we are talking about some kind of description of a true scene. We're like describing a crime or solving some puzzle. And there really isn't a whole bunch of answers. There's just like one solution, and we're sort of discussing those solutions, and we don't necessarily agree. So, it really has to be a debate. It can't really just be conversation about disagreements. You can't have conversations about disagreements. You have to sort of have arguments. And, people really aren't very good at doing arguments without making it personal or some kind of crap. So that's just the sad part. And it's really hard to engage anybody in arguments because I guess nobody wants to be wrong. So they figure they can't be wrong if they're not tested. If they're not forced to be right, prove themselves right, then they're not wrong until proven wrong or something like that. So anyway, there's this channel, Understanding Physics by Dave. That's what it's called. Guy speaks well, doing physics. But, I would argue that the way he's describing, in this case, gravity, and he's trying to get to the more complex parts, I suppose. But, I mean, it just starts off all wrong in terms of, all right, so he talks a little bit about the inverse square law. And to me, it's just so obvious that you should do that in the context of things that are just like it, which is light is just like it. Does basically the same thing. That didn't work. Oh, that was, yeah, I hit the wrong button. That's why it didn't work. I'm getting old. Just tired and useless. Anyway, so I mean, the sun is obeying the inverse square law in terms of how it's radiating light. It's spreading light. Okay, you can sort of understand spreading in one dimension, but it's really spreading in two dimensions. So that's the square part. It creates an area. So at twice the distance, you have 4 times the area that you're spread the light over, which means it's dimmer and dimmer and dimmer. So every half the distance, you diminish the amount of light by 4. And gravity does the same thing in reverse. So to me, that's making it kind of obvious that, like photons, it's this thing that can push. It's this thing that can pull, however you want to think about it. But frankly, it's stuff, okay? Photons, like sunlight. It's stuff. It makes it so much easier to understand it as stuff. And it's a field of stuff. And the simple argument is there's a certain amount of stuff going one way, and there's a competing stuff going the other way. And if you're in a place where there's more stuff going one way than the other way, then you're going to live in that differential. And for us on the surface of the Earth, it's 9.8 meters per 1 second. Okay, not seconds squared. You can just basically understand it's kind of just something you acquire based on that pressure. There's a stream, a wind, and it blows you or pushes you in a direction, and as you get pushed, you're acquiring a force. You're carrying it, and you'll end up hitting something with that force, and it's proportional to your mass. You have a big sail, you collect lots of force. You have a small sail, you collect a little bit of force. So mass is essentially your catcher, and it will basically, you'll find out how much you collected when you hit the ground. So a hammer falls, it weighs a lot, it collected a lot of F. Okay, a feather has a very small sail, it collected very little F, so it has very small F. Okay, and so when they hit the ground, you'll see them give up what they collected. It's that simple. They're really collecting momentum, and everything that has a contact relationship with a surface is right now in contact. And I could argue to the physicist Dave that you can sort of understand this stuff, that if I have a scale and I put a weight on it, a mass, and it has a weight, that is, it deflects the spring, and then I turn that scale sideways with that deflection in the spring, and then I release it, there's going to be a certain release velocity that's going to essentially duplicate the mass. So the mass that's stationary is applying a force that's equal to a certain amount of momentum. And you can find out by simply just tipping the scale sideways and allowing it to move. And I would argue it's 1 mile per hour. And so any object, elephant or mouse, I swing an elephant into the scale, I swing a mouse into the scale, I give them 1 mile per hour, okay, and they'll both weigh their mass. The elephant will weigh heavy, the mass will weigh light, okay, at 1 mile an hour. So it all works out quite nicely. So in the section of video I'll play right here, he's going to argue that there's this MGH formula that has some sort of credibility. Now, it doesn't work over large distances because your gravitational potential changes. So obviously we do know that we're on a round Earth and it's the r squared thing is happening. But for certain regions, you could essentially just forget about it because it's so consistent over that area, it doesn't matter. So you can basically say within, hundreds of meters, the 9.8 is going to be fairly consistent as a force differential you're going to be in. And the fact is you can drop things and you can sit there and see how much velocity they acquire. So Galileo did all these experiments and you got the 1, 3, 5, 7, which again is just squaring. It's showing you the inverse square law in its consequential view of it. So MGH basically says, okay, that something, this energy, you drop something 4 times the distance, that somehow you actually did do 4 units of force when it was only 2 units of time. So 1 unit of distance is 1 unit of time, and 4 units of distance is only 2 units of time in the 9.8 differential. So you're in the differential, it's 9.8. It's just about how long the wind's blowing on your sail will pretty much tell you how much force you can collect. How much water is flowing in the stream will tell you how much force you can collect. And it's about the time, not the distance, the height. The height doesn't tell you the amount of force you collect. So obviously I would argue that it's twice the time. You're only going to weigh twice as much. And so clearly it's twice the momentum because it's twice the velocity. So you only get twice the velocity, twice the time, twice the weight. So why are we arguing that somehow this is 4 times the energy? That seems totally inappropriate is the argument. Okay, there's no reason to do that for energy thing because you can understand in the first unit of time you got this little tiny distance. And the second unit of time, you got this giant distance because of your velocity. But it's only 2 units of time, and you only collected 2 units of force. All right. You can also understand it as the rolling object thing. So I give something twice the velocity. It will roll, 4 times as far, but it will be going half its speed, 3/4 of the distance down the track. So you kind of know the friction isn't even. Okay, because this going 1 velocity will be exactly the same as this whole path here going 1 velocity. So these things will be exactly equal. And the fact is this is the same time and this is actually going to be the same force. You disposed of the same amount of force through friction because you had less friction here as you did here. The friction was much greater because your velocity was much slower. You put more pressure on the ground. Oh, sorry, that wasn't in the image. So it just doesn't work, this idea. It's MGT. It's about how long you're in a force differential that will decide. MGT. That's the real one. That's the one that always will work in any circumstances. How much time are you in a force differential? Now, obviously, when the differential is changing, that is, if you're going from a point where it's 4.5 gravity and then it's 9.8 here and you're traveling through this, but your velocity is increasing here, that is, you're going through this part of the gravity very quickly, this part very slowly, then you have to do more complex math to figure out exactly how much you're collecting. I don't think I need to go into the other, there's countless, literally countless arguments. Dave, come on, Dave. You know this experiment. I take the 5 mass and I give it a 10 velocity. I merely pour, okay, 5 more mass into it. It could be just water. It could be a bucket. I just fill it up with 5 mass worth of water. I end up with a 10 mass object, and it's going to be going 5 velocity. So by the kinetic energy theory, I automatically have to lose half the energy. Where did it go? I didn't make sparks. I didn't shoot anything to the moon. If I have 100% almost of the momentum, how could I move something or create heat and not use momentum? It's just it's a complete paradox. There's no way I could break a piece off and shoot it off and still have the same momentum. That would be the same as me saying I can have a bowling ball hit a bowling pin, give the bowling pin energy, and the bowling ball doesn't lose any momentum. I can't do that. I can't make this hot. I can't make pieces fly off. I can't make sparks. I can't make sounds without using the momentum. And so there is no excuse for this. Half the kinetic energy just disappears. It's not logical. Alright, should be back logical. Yeah, it's not logical. I think that's what I was saying. So I did finish off with stuff you didn't see. So, come on. 1,000 atoms going 1 mile an hour, same as 1 atom going 1,000 miles an hour. And it's not one of them isn't 1,000 times more joules. It's not 1 joule for this and 1,000 joules for that. It's just, and I could just make the numbers more and more crazy by just increasing again. I can make it 10,000, I can make it 100,000, I can end up with numbers in the millions of joules. It's just totally breaks all kinds of mechanical physics. It just completely ruins physics. It's wrong answers. I mean, there's no evidence that any of this happens. There's no evidence it takes 4 times the energy to spin a motor twice as fast, or 9 times the energy to spin a motor 3 times as fast, or 16 times the energy to spin a motor 4 times as fast. There's no physical evidence for this. And you're all selling it, and it's just not right. And it's, frankly, you shouldn't want to be selling, frankly, something that just seems pretty much just like a religion, not really about being any kind of physics. So anyway, he goes on, and he makes talks about the, gravity wells, and frankly, they're not wells. Okay, a gravity well as an illustration is terrible because it just makes you think in 2 dimensions. It makes you, basically, it's saying gravity. You're using gravity to model gravity. It's really cheating. And the idea of a real pushing force, okay, the idea that there's just like photons, it's just the reverse. There's more stuff coming down from the top than there is stuff coming up from the bottom, and you're stuck in that differential. Much more logical.
Potential energy. We worked it out in the last question. This is a very, very good video. This idea of...
So it's really bad. It's got millions, tens of millions of views, and it's a really bad illustration because of the amount of friction that this causes. And so it doesn't give you a realistic view of what happens. Because in a real gravity well, things aren't going to go into orbits. Things are going to crash. Either they're going to crash right into it, or they're going to fly back out of it. Nothing starts, nothing poofs into existence like halfway down the well. So we know everything that's going to go into the well has to come into the well with velocity. And the fact that it's coming in with velocity means it's going to have to, if it misses hitting anything, it's flying the hell back out. And and the other option is it crashes right into the thing. But there's no gravitational capture in the absolute reality, and the only way you can get gravitationally captured is you have to do something to take away some of your velocity so you're stuck in the well. Because you won't be stuck in it otherwise. Otherwise you're flying back out. And so it's not showing real gravity, it's just a toy. It's a poor illustration because it really isn't showing. Now, once he starts throwing things in one direction, he throws some in the other direction, and it sort of shows how everything ends up going in one direction, which is sort of what the solar system has demonstrated, that everything sort of ended up going in one direction around the sun. That's a good illustration, just showing that, when it's a crowded field, all the energy is going to start blending with each other, and whatever has the net extra energy is going to be the direction that everything ends up rotating. I mean, those are kind of good illustrations, but again, it requires you to have interactions for you to get caught in an orbit. You can't get caught in an orbit unless something takes your velocity away. These are, yeah, it's an important fact, and it's just blown over. Physics doesn't pay any attention. So you're talking about the hard bits of gravitation, and this illustration is dissecting, taking out all the hard bits. It's a three-dimensional thing. It's it's not two-dimensional.
Potential wells. There's a few of these. I think this is probably the best one. And this guy with a big rubber sheet, and he puts some big
It's spandex, actually, so, but whatever. Same difference.
In the middle, and that represents our gravitational well, and he demonstrates satellite motion and all sorts.
Right, and it really isn't demonstrating the actual problems and the actual way you have to get around these things, like the fact that we have to give things velocity in the direction we want them to orbit. It's not just merely flying to a location and saying, there, I've gotten to an orbit. I have to have a velocity, okay? And so, it's much more complicated.
I used to do this. One of my technicians made me a fantastic rubber sheet like this,
Yeah, so, no comment on that. I mean, I don't think it's a fantastic way to illustrate gravity, but you can't really take the friction out, and the friction makes it behave quite different than the real event would behave. So I don't think it's a really great way to do the science of gravity. So I guess I'm being critical. Sorry. So yeah, you can't do that. So you probably won't watch the video. You probably won't pay any attention. You probably won't make any counter arguments because nobody has. And frankly, it's just demonstrating that physics has a closed mind. It's pretty much just a religion. They have their little formulations here, 1/2 mv squared. So now you just start making these preposterous amounts of joules of energy that you've never collected. I mean, they never collected the 2,000 joules the bullet has versus the 2 joules of the gun's recoil. I mean, it doesn't make any sense. It violates Newton's third law. And again, you're stuck with this paradox. I used the ballistic pendulum as an example. I mean, you shoot the bullet into the ballistic pendulum, you conserve 99% of the momentum, yet you lost 99% of the kinetic energy. How can I lose 99% of the energy? That is, I can make heat, I can make pieces fly off, I can do all kinds of crazy stuff, and I don't use any momentum. I mean, that's a paradox. It breaks physics. You can't do that. You can't claim you made something move in this universe and then not show me something that gave it the momentum. Something had to lose momentum for you to have momentum. I put a boat in a stream. The stream loses momentum to give the boat momentum. Nothing can get momentum for free. And so there's no way to account for this half the energy loss except for the fact that you have an arbitrary, silly equation invented by a profoundly religious, kooky fellow. It's Leibnizian mechanics. It's not Newton's mechanics. It's not Newton's formula. It's not Newton's point of view. Newton opposed it directly for 40 years. He said no, no, no to 1/2 mv squared. It was just mv squared there. He said no, no, no. It's not the right answer. It's silly. It's wrong. 4 pounds dropped 1 foot is not the same as 1 pound dropped 4 feet. Okay, so anyway. Let's see what happens. He probably has me already blocked. I probably previously commented and I'm blocked because I disagree with their fable about what energy is in this universe. And energy is not 1/2 mv squared. Energy is momentum. Energy is pressure. Energy is weight. Work is weight, pressure. These are the things the universe runs on. It doesn't run on any of this arbitrarily faked square thing. It's 9.8 meters per 1 second. That's Newton's formula. Every 1 second you get 9.8. You don't get In 2 seconds, you get 2 units of 9.8. You don't get 4 units. And your velocity proves you didn't get 4 units. I can't put 1 pound on a scale. Come on, do I have to do all of these? I mean, the kinetic energy formula basically says this, Dave. Come on, admit it. Kinetic energy formula says I put one thing on the scale and I read the scale's weight. And then I put a second thing, exactly the same thing, on the scale, and somehow twice the weight is 4 times the energy. Somehow I got 4 times the energy. So putting this 1 on here somehow equals 3. Even though it's only 1. I did the same exact action. And now I have 4 times. I got 1 unit of energy. Now all of a sudden I have 4 units of energy. Come on. You know that can't be true. Come on, research it. Do a little research. You'll find out that these Chardonnay round things, denting clay, bad idea, not a good experiment. Dropping things in sand and then being surprised that when you drop something light fast, the sand goes further isn't also a very good way to find out the total energy. Rolling an object on a surface, not a great way to find out the object's total energy. You know, just going by the distance it rolls. Because obviously when it's rolling fast, it's going to have less contact with the ground. It's going to lose less energy to friction. When it's rolling slow, it's going to have a lot of contact with the ground, going to lose a lot of its energy to friction. Come on. Play along. Give me your insight. Explain to me how I am so full of junk and garbage. Explain. Show me where Leibniz produced a great theorem where he showed lots of evidence. You know, where he actually did the experiment. He actually dropped the 4 pounds 1 foot, and then he dropped the 1 pound 4 feet, and he showed how there was, you know, the same energy, the same weight on a scale. I mean, the very fact that physics hasn't even done the experiment, right? They haven't even taken a silly little scale, dropped 4 pounds from 1 unit of distance, and then dropped 1 pound from 4 units of distance, and then shown that they weigh the same, that they collect the same spring compression. All right, enough said. All right, till the next time, and such and so forth and whatnot. Hopefully we'll get a response. We'll see. I've done my part. I mean, I can just do my part here. So anyway, this has been a DraftPhysics.com, DebatePhysics.com video presentation. So on the DebatePhysics.com website, there are a bunch of 5-minute videos just going through all these different arguments, levers, 10-ton, 5-ton trains. I mean, you know, in all these years, we don't have the video of a 5 mass going 10 and a 10 mass going 5, and you know, they put a little string between them and have a tug of war. Because the 5 mass going 10 is supposed to have twice the energy. I mean, it really should pull the other object in its direction. We really should be able to see that it has twice the energy. All right. Never done. All right. Till the next time and such.